Hello everybody, welcome to Pre-Calc Lesson 3.6, Introduction to Synthetic Division. So before we get to synthetic division, I'd like to review a process from elementary school, hopefully from elementary school, long division. So don't bother writing this down, but just follow along on the screen. Let's say I wanted to take 1,234 and divide it by 7. So I would create this long division box, and what I would do first is I would ask myself, how many times does 7 go into 12? Well, that answer is 1, so I put a 1 up top. Then what I do is I multiply those two. So 1 times 7 is 7. What comes next is subtraction. 12 minus 7 is 5. Then what do? Well, then I bring down my next number. That is a 3. I ask myself, how many times does 7 go into 53? And that answer is 7. So put that up top. And then again, we multiply. 7 times 7, that's 49. And then you subtract. That gives me 4. Next, we bring down this 4. So I've got 44. How many times does 7 go into 44? That is 6. 6 times 7 is 42. I subtract one more time, and I get a 2. Well, what does this 2 represent? I don't want a decimal here. This 2 represents a remainder. So I would say something like R2. Or what you could do to create a fraction is you could take that remainder and put it over the divisor, 7. So my answer would be 176 with a remainder of 2, or 176 and 2/7. All right, and both of those are going to apply to synthetic division. All right, so let's take a look at our long division first of polynomials. So I have x squared minus 5x plus 6 divided by x minus 2. All right, so the x minus 2 is going to go outside, and x squared minus 5x plus 6 will go underneath. Here's the first question you're going to ask. How many times does x go in to x squared? Well, that answer is x. Now what I need to do is I need to multiply x times x minus 2. I'm going to write that underneath. Don't do any signs yet unless they're negative. So x times negative 2x is negative 2x. X times x is x squared. Now, if you remember from the long division, we now subtract, which basically means to negate both terms. So I subtract, and if I subtract a negative, it becomes positive. Now we'll combine like terms. Negative 5x and a positive 2x is negative 3x. And if you did this correctly, these terms here will cancel out. Now what do? Well, now I bring down that 6. Plus 6. Ask yourself, how many times does x go into negative 3x? Well, that answer is negative 3. Then I multiply negative 3 times both of these. So that's going to give me a positive 6 and negative 3x. Now remember, I didn't subtract yet. Now I subtract, change both signs, and if you notice, everything cancels and I get a 0. That is your remainder. So the answer to this question, when I take x squared minus 5x plus 6 divided by x minus 2, the answer is x minus 3. All right, let's look at one that's a little bit more challenging. So I'm going to take x minus 3, put that outside. Underneath, I've got 3x cubed minus 10x squared plus 5x minus 6. First question, how many times does x go into 3x cubed? That's 3x squared. Now I multiply 3x squared times both of these. So 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. Now you subtract. Negate, negate. These cancel, as they should. Negative 10x squared plus 9x squared is negative x squared. Now we bring down plus 5x. Now we ask ourselves, how many times is x going to negative x squared? So that's going to be negative x. And now I multiply negative x times both of these. That's negative x squared, and that's positive 3x. Now subtract. So you negate both of those. That becomes negative. And those cancel as they should. 5x minus 3x is 2x. And I bring down my last term, minus 6. Ask yourself, how many times does x go into 2x? And that answer is 2. Multiply both of these by that 2. So that's going to give me a 2x minus 6. Now subtract. And notice both cancel. You get a remainder of 0. So the answer to this question, if you were to divide these polynomials, would be right here, 3x squared minus x plus 2. Now, a little bit of review here. We did that last year in Algebra 2. We are not going to do this anymore. Way too long. Look at all this writing. All right? But it relates to synthetic division. Take a look at our first example here. Now, you're like, well, where are the variables? Well, we're just going to go through the mechanics of synthetic division. I'm just going to write out the steps first. Here they are. 1. Bring down. What does that mean? Well, I bring down this number. 3. Excellent, all right? Step 2, what do we do next? We multiply. What do we multiply? The number in the box times the number at the bottom. 3 times 3, that's 9. Okay? Then what? Well, you simply add. What's a little tricky up above is you have to subtract each time. We'll talk about why we're adding here. So I just add these two numbers. Okay, so that's going to give me a negative 1. And then step 4, repeat steps 2 and 3 until finished. So bring down, multiply, add. Multiply, add, multiply, add, multiply, add. You just keep going back and forth. So now what I'm going to do is I'm going to multiply these two numbers. All right, well, that's negative 3. Now I add these two numbers. Okay, that's 2. Now I multiply these numbers. Okay, that's 6. Now I add these two numbers. That gives me 0. There's my answer. That's it. Now, we don't know what these numbers represent at this point, but we just practiced the mechanics. So let's see where we get these numbers. Where does that come from? Where do these come from? All right, so we're going to apply a little deeper meaning to this process. All right, in example 2, I'm going to set up the synthetic division, and I want you guys to predict where these numbers come from. So if I were to divide these polynomials, inside my synthetic division box, I would have a 2. The numbers outside the box would be 1, negative 3, 5, and 1. And now we're going to go through that process up above. Okay, so you can see over here on the right, I'm going to bring down, multiply, add, multiply, add, multiply, add until I'm done. So bring down. 1. Multiply. 2. Add. Negative 1. Multiply. Negative 2. Add. 3. Multiply. 6. Add. 7. Great. That was simple. But what does it mean? Where do you think this 2 came from? Well, it has to do with this right here. If you notice, my factor is x minus 2. what would the root be from that? The root would be positive 2. So this number here is the root, not the factor. Okay, well, where do these numbers come from? Well, if you notice, that's a 1, that's a -3, that's a 5, and that's a 1. So those right here are coefficients. Okay, well, what's left underneath? What do these numbers now represent? These numbers here represent the coefficients of your answer. And the last one is the remainder. So the process of synthetic division is a piece of cake. Bring down, multiply, add, multiply, add, multiply, add until you're done. Understanding what the question asks for is a little bit more challenging. Notice what this says. Take this cubic polynomial, divide it by this binomial. So what type of answer do they want? They want another polynomial. How do you get it? Well, these numbers right here will give you the coefficients of your answer. If I take a cube and I divide it by an x, I'm left with an x squared. And that would be an x, that would be a number, and that's your remainder. This is how you write your answer. All right, the variables are not in here because it kind of clutters things up. We just want to use the simple numbers. So the answer to this question is x squared minus x plus 3 with a remainder of 7. Okay, let's try another one. So how am I going to set up my synthetic division? Let's see where I get the numbers from. I start with the number that goes in the box. That's going to be the root that comes from this factor. The root is 2. So I'm going to start this by putting 2 in the synthetic division box. Now, what numbers go here? Coefficients. This one has a little bit of an issue because if you notice I go from a 4 to a 2. So I'm missing a cube. So when you go to write the coefficients, you have to account for every power of x in decreasing order from the first one. So I have 1x to the 4th. I have a 0x cubed. So I have to put a 0 in my synthetic division. I have a 6x squared, I have a -7x, and then I have a 12. So this is the x to the 4th, that is the x cubed, that is the x squared, that is the x, and that is your constant at the end. All right, so now let's go through this process. This is the easy part. Bring down, multiply, add, multiply, add, multiply, add, multiply, add. All right, double check my arithmetic. That looks good. So now, what do these represent? These represent the coefficients of the, here's a new vocab word, depressed polynomial. It's depressed because it started as a 4th degree. You divide it off an x, it's going to end up as a cubic. So that's going to represent your cube. There's your squared, there's your x, there's your constant, and this is your remainder. Notice again, I'm taking a polynomial, dividing it by a polynomial. My answer is a polynomial. This is not your answer. This is the work that's going to get you your answer. So I would start with the 4th. I'm going to have a 1x cubed plus 2x squared plus 10x plus 13, and this is going to be a remainder of 38. So this is one way you can express your answer. Okay, let me just move that over here because there's another way you can express your answer. Remember what we did with the long division. X cubed plus 2x squared plus 10x plus 13 plus, Remember what we did with that remainder. We put the remainder over what you divided by. This is another way you can express your answer. Both of those will be acceptable. The only time you'd have to specify one versus the other is maybe if it's multiple choice and you have to figure that out, or if it says express the answer without a remainder. So this is without a remainder. This is with a remainder. Okay, speaking of remainders, let's talk about the remainder theorem. All right, the remainder theorem is if p of x, which represents a polynomial, is divided synthetically by a value, we'll denote a, the remainder equals the y value of p of a. What does that mean? Let's take a look here. Example 4, it says find p of 3 by substitution and synthetic division. Well, we know how to do this by substitution already. If I want to find p of 3, I'm just going to plug 3 in for all my x's. 3 to the 4th minus 3 times 3 cubed minus 2 times 3 squared plus 3 plus 5. For the sake of this video, I'll save you guys from going through this by hand, and I'll just plug it into the calculator, and I got negative 10. So I know p of 3 equals negative 10. But what if I did ask you to do this, and we were dealing with a large number, and I wanted you to do it without a calculator? That's when we could use synthetic division. The process might be a little bit longer, but the numbers are much smaller and easier to deal with. So if I want to evaluate p of 3, notice, that is my x value. That's my root. So if I'm setting up synthetic division, I'm going to put the 3 in the box. Next thing I notice, my exponents, 4, 3, 2, 1. So I don't have to add any zeros. I'm just going to write these coefficients. So 1, a negative 3, a negative 2, a 1, and a 5. 1, negative 3, negative 2, 1, and 5. And watch how fast we go through this. Now, I don't want you to rush because most of the mistakes we see in this unit, believe it or not, is simple arithmetic. But we bring down, and then I multiply. And then I add. And then I multiply. And then I add. Then I multiply. Then I add. Then I multiply. Then I add. Now, this question doesn't want a polynomial for an answer. It says find p of 3. So you're going to answer this question with p of 3 equals something. What's that going to equal? The remainder. So first of all, I would write my answer as p of 3 equals negative 10. But why is that? It's because of this remainder theorem. If p of x is divided synthetically by a value a, so I took this and I divided it by 3, the remainder is the y value of p of a. So graphically what we've done, this is a positive 4th degree. It looks like this. If my x value is 3, I know the y value is negative 10. So I've basically found a coordinate on this function by synthetic division. I chose an x value of 3 because that's what the question wanted me to find or choose. And there's my y value. All right, let's try a couple more here. Find p of 3 synthetically in this function. So it specifically says synthetically. That means I have to use synthetic division. That's going to go in the box. 3. My coefficients is going to be a 1, a negative 8, 19, and negative 12. 1, negative 8, 19, negative 12. Bring down, multiply, add, multiply, add, multiply, add. Oh. So again, the question wants me to find p of 3. I'm not listing a polynomial. I'm saying p of 3 equals 0. Right? That tells you what p of 3 is. Well, what do we know graphically? Well, positive cubic, here we go. X value is 3, Y value is 0. Well, what does that mean, 3, 0? Guess what? That means it's a root. Here's your x-axis. So that gives us the factor theorem. If P of x is divided synthetically by C, and there is no remainder, so your remainder is 0, then C is a root and x minus C is a factor. So in this, we're going to have several theorems. I know usually in, previous math courses, you get a theorem like, yeah, okay, whatever, but you need to know all these theorems, all right? So if you're not writing this down, you need to write it down. You're going to be tested on the theorems in addition to do the work. All right, so let's see here. Is x plus 4 a factor of 2x cubed minus 4x squared minus 3x plus 2? Well, how do we know? Well, we have to use the remainder theorem, or the factor theorem, sorry. We're going to divide this synthetically, and if our remainder is 0, then the answer is yes. If we have some other remainder, then the answer is no. So you just got to be careful here, because remember what we said, I'm not going to put a 4 inside. The root, or the x value, equals negative 4. So that's what's going to go inside your synthetic division box. Negative 4. How about our coefficients? We have a 2, a negative 4, a negative 3, and a 2. So those numbers are going to go here. 2, negative 4, negative 3, 2. And then this is the easy part. Bring down, multiply, add, multiply. Whoa, getting big here. Add, multiply. 4 times 45, that's 180. Negative 180. Add, negative 178. Now, here's the work. The work's going to be the same from here on out. Synthetic division, over and over and over and over again. How do we answer the question? First of all, is this a factor of that? It's a yes or no question. Judging by my remainder, no. So I'm going to say no. Why or why not? Because the remainder does not equal 0. If it went on to ask a follow-up saying, okay, if it's not a factor, can you give me a point on this function? Sure, you can. Because remember, this is my x value, and your remainder is your y value. So you could say negative 4, negative 178 is a point on 2x cubed minus 4x squared minus 3x plus 2. All right, make those connections. All right, example 7. Is x plus 1 a factor of x cubed minus x squared minus 10x minus 8? So again, I'm not going to use a 1. The root there would be x equals negative 1. That's what's going to go in your synthetic division box. So I have negative 1. Coefficients I'm going to use 1, negative 1, negative 10, negative 8. 1, negative 1, negative 10, negative 8. Bring down, multiply, add, multiply, add, multiply, add. All right, so notice, remainder is 0. Is that a factor? Yes, because the remainder equals 0. So now it says use the depressed quadratic to find the other factors. My depressed quadratic comes from this. Remember what these numbers represent. They represent the coefficients of the depressed quadratic. I started with a cubic and I divided off an x. So this represents an x squared. That's an x. That's my constant, and that's my remainder. So the depressed quadratic, I know it doesn't say to state it, but we should, is going to be x squared minus 2x minus 8. So now to find the other factors, notice, well, hey, this is just a quadratic. So now all I need to do is set that equal to 0 and solve. So x squared minus 2x minus 8 equals 0. That factors x minus 4. X plus 2 equals 0. So x equals 4 and negative 2. So here are my factors. I guess I could have stopped right there, actually. And here would be the roots, which I'm going to need to sketch this. I got a little ahead of myself. Sketch P of x. Well, let's think back to earlier in the lesson. What do we know about this polynomial? My roots. X equals 4, negative 2, and from up above, negative 1. That is a root. All right, so 4, 1, 2, 3, 4, negative 2, and negative 1. So here, here, and here. Next, I need to know my y-intercept. Well, the y-intercept is going to be easy because if it's not in factored form, remember, it's just what's on the end. Because remember how you get it. You set x equal to 0. So that'd be a 0, that'd be a 0, that'd be a 0. All this stuff is 0. There's your y-intercept, negative 8. I'm just going to put a mark down here, call that negative 8. So my function has to go through those points and the tails. Let's see, it's a positive cubic, so my tails are going to look like this. Notice I don't have a double or a triple root. It's going to pass through all of these. Passes through, comes back down here. It's going to go a little bit below that and then go up through. All right, so cool. We're going to be using synthetic division to sketch our polynomials. And a cubic is just the beginning. We're going to go to quartic, 5th degree, 6th degree. All right, two quick practice problems here. Evaluate the polynomial at p of 2, p of negative 3, and p of 4. So we're just going to do synthetic division 3 times. All right, so let's do, I'll do a over here. 2 is going to go in the box. My coefficients are going to be a 3, a negative 13, a negative 11, and a 5. All right, so 3, negative 13, negative 11, and 5. Bring down, multiply, add, multiply, add, multiply, add. P of 2 equals negative 45. All right, let's do B over here. Negative 3. Same coefficients, 3, negative 13, negative 11, and 5. Bring down, multiply, add, negative 22, 66, 55, negative 3, that's going to be what, negative 165? Add those, negative 160. I guarantee you that would be faster than plugging in a negative 3 and working that out. And lastly at 4. So this will be C. 4, same coefficients, 3, negative 13, negative 11, and 5. Bring down, multiply, add, multiply, add, multiply, add, negative 55. Way faster than if I tried to plug in a 4 and take 4 cubed times 3 minus 13 times 4 squared minus 11 times 4 plus 5. I just did it in about 10 seconds. All right, I could not do it that fast by substitution. And the last one. Is x plus 1 a factor of 2x cubed minus 3x squared minus 2x plus 3? If so, find the other factors. So in synthetic division, remember, this is the tricky part. I got to put a negative 1 in the box because it's the x value. It's the root. Coefficients will be a 2, a negative 3, a negative 2, and a 3. Bring down, multiply, add. Multiply, add, multiply, add. First question, yes. I guess it doesn't ask. It just says it is. So I'm going to say yes because the remainder is 0. Find the other factors. So now I have to use the depressed polynomial. Remember, I started with a cubic, I divided off an x, I'm left with a squared. So this is 2x squared minus 5x plus 3. There's my depressed polynomial. 2x squared minus 5x plus 3. It says find the other factors. Let's factor this. It's got to be 2x and x. Signs are the same, both negative, and your only choice is 3 and 1. All right, so since the signs are the same, though, we got to be careful. The 3 is going to go here, and the 1 is going to go there, because that gives me negative 2x. That gives me negative 3x. I put these two together. That gives me my negative 5x. So it doesn't ask for the roots or anything. I don't have to sketch it. It just says what are the other factors. There you go. Okay, guys, I know this was a long lesson, but it's an important one. Intro to Synthetic Division, brand new for everybody. As usual, guys, if you have any questions, don't hesitate to reach out. And thanks for watching. We'll see you in class soon.